Assalamualaikum warahmatullahi wabarakatuh. So students, I will explain to you the assignment that I've given to you. So I have divided each of you to a specific date to determine the reference evapotranspiration. As you can see, that this is the information given to you. I took some information from the Jumantono Weather Station. As you know that we have the weather station over there and we can monitor time by time. So for example, this is the performance, the console of the weather monitoring from the weather station in Jumantono. As you can see, there's a temperature data and then relative humidity, rainfall, and then air pressure. And then here there's a wind speed. Okay, and then solar radiation and also the wind direction. So from this information, I download the data. Okay, I download from I think it's from it's from I downloaded on 28th March. So I think the data was from let's see first. It's from 26th of February. Okay, so I already divided to each of you for a specific date of determining daily reference evapotranspiration. Aquila 27 February, Landra 1st March, Bian 3rd March, and the last is Ray is 18 March. So I download the data and I already converted to Excel and I upload the data to the drive. You can see here, you can check the data from here. Now I will tell you how to utilize this data. Maybe if you see it's temperature data, for example, here. Oh, please wait. So the data, the temperature, you can see it's from 26 February, 12 p.m. until so many. It's every 1 minute. This is recording of weather data every 1 minute. Okay, 1 minute, 1 minute, 1 minute. So it's really so many data, of course. For example, 26, it's reached until, I think it's until like here, from until here. Okay, 640 row number 640. And the 27th of February starts from row 641, for example. So you should check from the data which is your date for the assignment. Okay. So for now, I will give you an example of how to determine your data uh, from the Jumantono data. As we know that you will have to determine the maximum and minimum temperature, maximum and minimum relative humidity, the wind speed, and the sunshine duration. First is I will give you the example of February 28. Okay, this is how determine the data from for February 28, 2025. First, check the location. So from the word I've given you, the location in Jumantono Station. So if you right click this point in the Google Map, you will find out the location, the coordinate of the location. Okay, so the coordinate is minus 7.62985. Okay, and then 110.94794. It means that this location is located at the latitude 7.6 2985 south. Okay, because this minus sign means southern hemisphere. While the positive, if this is positive, means north. Okay, and then for the 100, it means that east. Okay, this is the east latitude. Okay, so now we know the coordinate of the location, the latitude, and the longitude. And also, this is given the information of the elevation. The elevation is 250 meter above sea level. Okay, so so you can see that this is the location 250 meter above sea level. We input the data into this here, the location. This is south and east, okay, and then the elevation. And then the next is determine the maximum and minimum temperature, okay. Maximum and minimum temperature, here we can see from this, from here, the temperature data, okay. So from here, the temperature data, what you can download this data, and then you can see this is the maximum is so in my case, for the example, is 28th February, right? For 28th February. So how to calculate this? What is the maximum? So from the 28th, this is from this time, okay, this time. I must find out 28th February is starting from row 2048 until so for the maximum is we should type the formula. Okay. Maximum of this 28, okay, 28 February until the last cell of 28 February. So we have to take the last cell. This is still 28. Okay, sorry. We've passed it. 28 is until here. Here, okay, 28th February. So start here and give the parenthesis. So we got that the maximum is 33.2. We put the number here. Sorry, here. Maximum is 33.2. And then do the same for the minimum temperature. Okay, do the same for the minimum temperature. So you can copy. Remember the cell number 2048 with 3458. This is for 28. We change this one become minimum. Okay, minimum. Minimum, it was 2848 until 3458. Okay, so we got the minimum temperature is 22.9 and we put here 22.9. So we already get this date, location, elevation, maximum and minimum temperature. Next is the maximum and minimum relative humidity. Okay, so that will be the same. You can download the data and you can calculate using the same maximum of this from 28 February until the last. You will get the maximum number. And then the minimum, same. Okay, from 20048, 28 February until the last, until 3458. So this is the minimum relative humidity, and you put here. And then next, wind speed. Okay, wind speed at 10 meters. We have the data wind speed is in meter per second here. Okay, in meter per second. So you can So here you can use this equation, average. Average from 28 February 00 hours. Okay. And then average means. And then you will get that the wind speed, the average is, put it here, 1.099. I think this is meter per second. Okay. And then next is the sunshine. Sunshine duration. So sunshine duration, we also have the report here, solar radiation. According to the World Meteorological Organization, WMO, we calculate the sunshine duration. This is the intensity of the solar radiation. Okay, the intensity of each time, each minute. So we can see here that at nighttime, it's still down in the morning. Nighttime, the solar intensity is 0 watt per square meter. So, according to WMO, World Meteorological Organization, they said that to determine the sunshine duration, it should start with the intensity of minimum 120 watt per square meter. Okay, minimum should be 120 watt per square meter. So we start from here. Okay, so the duration we start from this because it should be minimum 120 watt per square meter. So it starts from 6:59 a.m. Okay, and then we should observe one by one until it is totally minimum 120. You can see here, oh, it's low. Okay, so it's here. 124 is the lowest at 1:48 p.m. Okay, so we put them. So you note the time from 6:59:45 a.m. to 13:48:44 second p.m. Okay, so you put them here. This is put them here and calculate. Calculate 6 hours, 48 minutes, 29 seconds, and convert them all to hours. So we got the 6.975 hours. Okay, so we already get all the information from the data, and then you can calculate using the Penman monthly. Okay, good luck, and please try to do the assignment, calculate the difference evapotranspiration using the formula have been given to you. Thank you.